So this lesson is going to teach us about percentage composition. And percentage composition naturally follows on from being able to calculate the formula mass of a chemical. Now, what we mean by percentage composition is, for example, if we had calcium fluoride, you might get asked what percentage of calcium fluoride is calcium. Now, that might seem like a simple question. You could say, well, there's 3 atoms inside it, 1 of calcium and 2 of fluorine, so a third of it is calcium, which would be about 33%. But that's not how we can do this, because calcium weighs a lot more than fluorine. Calcium weighs 40, has a mass of 40, and fluorine has a mass of 19. So when we're working out percentage, we're always having to deal with atoms that don't weigh the same amount of one another. So percentage composition is a way of being able to answer this question correctly. And the first step is always, what is the formula mass? Okay, well, the formula mass are 2 elements. We have calcium, we have fluorine. From the formula, there's no number after calcium and there's no brackets, so we know there's 1 of them. Fluorine, we've got the number 2 here, so we know there's 2 of them. We then look up the data booklet, page 7, to find out what each element weighs. Calcium weighs 40, fluorine weighs 19. We do the multiplication. We get 40 and 38, and we add them up, and that gives us 78. So that is the formula mass. Now what we want to do now is we want to work out percentage composition. And percentage composition is mass from your element divided by formula mass multiplied by 100. So your mass from your element is going to be this one here after it's been multiplied, or here. Your formula mass is that one there. So if we do percentage composition of calcium, well, what we're going to do, the mass from the element is 40. So mass from our element is going to be 40. Our formula mass is 78. We do that in the calculator first, and then we multiply it by 100. So again, it's chemistry. You can use your calculator whenever you want. I've got my calculator here. I've opened my bracket. 40 divided by 78, closed my bracket, no, it's not so easy to see, and then I multiply it by 100, and that gives me 51.3%, and I've rounded that to the nearest 1 decimal place. If now I do it for fluorine, so percentage fluorine is going to be here, going to be 38 divided by this, 78, and then multiplied by 100. That equals 48.7. So it's this number after it's been multiplied divided by your total ground formula mass. And one way that you can check, have you done it correctly, is if you add these two numbers together, you should get 100. And 51.3 plus 48.7 gives me 100. So I know that I've done it correctly. So we're just going to do two more examples of questions like that so you can see how it's done. So the next one, I'm going to do aluminium nitrate. And we're going to look for the percentage of oxygen. So step one is always work out what the formula mass is. So I've got aluminium, nitrogen and oxygen are my elements because I've got capital, a capital, a capital. Aluminium, no number after it, so there's one of it. Nitrogen, no number after it inside the bracket, so that means there's one, but there's a 3 outside the bracket, so that's 1 times 3, so that means I've got 3 of them. And oxygen, well, 3 inside the bracket and a 3 outside the bracket, so that's 3 times 3, which means it's times 9. And then going to look up the mass of each one on page 7 of the data booklet. That's 27 for aluminium, 14 for nitrogen, and 16 for oxygen. I then need to multiply. So 1 times 27 equals 27. 3 times 14 equals 42. And 9 times 16 equals 90 plus 54, 144. And then I add them all together. And I get 213. Remember, my percentage of oxygen, in this case, this is the total mass of oxygen, so it's going to be 144. And we're going to divide that by the formula mass, 13, and then we multiply it by 100. And when we do that, I've got my calculator out again, 144 divided by 213, and then I multiply by 100, and I get 67.6%. If I wanted to do percentage aluminium, well, what I would be doing in that case is that's going to be my top number, so it's going to be 27, but the bottom's not going to change, it's still going to be divided by 213, multiplied by 100. So 27 divided by 213 equals, multiplied by 100 equals 12.7%. So it's quite straightforward. Work out our formula mass, as always, and then it's whatever number here for the element divided by the total, and multiply by 100 to get our percentage. I'm going to do one more example, and I'm going to do NH4OH. Now this one, what have I got? I've got nitrogen, I've got hydrogen, I've got oxygen, and I've got hydrogen. Nitrogen, no number after it, so times 1. Hydrogen, 4 after it, times 4. Oxygen, no number after it, times 1. Hydrogen, no number after it, times 1. I then look up the masses. 14, 1, 16, 1. When I do that, I end up with 14, 4, 16, and 1. And when I add that all together, I end up with 35. Now this time, I'm going to be asked for the percentage hydrogen. Now to do the percentage hydrogen, I need to work out what is my hydrogen. What's going to go on the top line. Now normally I just look across one line, but we've got a hydrogen here and a hydrogen here. So I need to look at this number and this number. Add them together and that gives me 5. So my percentage hydrogen is going to be 5 divided by total 35. And then we multiply by 100 to make it a percentage. 5 divided by 35 equals 14.3%. So it's just to be careful, if the element appears twice and you're asked for it, make sure you add up both, or 3 times if it shows up 3 times, the number of times it's there, to get your total for that element, and then divide it by the formula mass. So that was a brief introduction to percentage composition. Hopefully that was clear, and thank you for your attention.